Hello and welcome to podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, node balancers, and a 40 gigabit public network, all controlled by a brand new API, you've got everything you need to scale up. And for your tasks that need fast computation, such as training machine learning models, they just launched dedicated CPU instances. And they also have a new object storage service to make storing data for your apps even easier. Go to pythonpodcast.com/linode, that's LINODE today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. Having all of your logs and event data in one place makes your life easier when something breaks, unless that something is your Elasticsearch cluster because it's storing too much data. Chaos Search frees you from having to worry about data retention, unexpected failures, and expanding operating costs. They give you a fully managed service to search and analyze all of your logs from S3, entirely under your control, all for half the cost of running your own Elasticsearch cluster or using a hosted platform. Try it out for yourself at pythonpodcast.com/chaos-search, and don't forget to thank them for supporting the show. And you listen to this show to learn and stay up to date with the ways that Python is being used, including the latest in machine learning and data analysis. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Corinium Global Intelligence, Alluxio, and Data Council. Upcoming events include the Data Orchestration Summit and Data Council in New York City. Go to pythonpodcast.com/conferences to learn more about these and other events, and take advantage of our partner discounts to save money when you register today. Your host as usual is Tobias Macy, and today I'm interviewing Orhun Parmaksiz about GrapheneX, a framework for simplifying the process of hardening your servers. So Orhun, can you start by introducing yourself?
Thanks for having me on the podcast, Tobias. It's an honor to be here. My name is Orhun Parmaksiz, and I'm a GNU/Linux enthusiast. Also, I'm studying software engineering. Most of the time, I like to deal with the GNU/Linux stuff, and I try to create projects for GNU/Linux also. And I can say that I'm a self-taught programmer and developer, and I still try to learn program languages and new technologies to implement in those projects. And my goal is to keep innovating and create projects that will help the community and the users.
And do you remember how you first got introduced to Python?
Yes, I think it was 2016 that I decided to learn Python. It was because my classmates at school were into it and they were doing some simple programs with it. And I was just curious about Python. So I go to a bookstore and I bought a book about Python. It was kind of a tutorial book, but when I got to the middle of the book, I was bored because the most of the time when I decided to learn a program language, I tried to do something with it, not just following a tutorial. So I left reading the book and I tried to create a simple project with it. And Python is a very simple and easy to do language, and there's a lot of libraries for doing various things. So I create my first Python project in 2016. Then it was a good project for me to learn Python, practice it, and I kept learning it, and that's how I introduced to Python.
And now you've been working on the GrapheneX project, which, as we said, is for hardening servers. I'm assuming Linux servers primarily. And I'm wondering if you can just start by explaining a bit about what we mean when we use the term hardening in the context of servers and security, and some of the common techniques and methods that you might use to achieve that hardening.
Yeah, of course. So when we say hardening, we mostly mean that securing a system by reducing its surface of vulnerability. I'll just continue with an example. So let's say we have a Linux server running and we misconfigured some files. We have some bad configuration files that will allow users to access the admin panel with the default password. It's a very common scenario. So if we change the configuration files and change the password as well, This process we can call this is a hardening process. And another example is disabling services or removing users on a system that will cause different things, like that will exploit the system. So these are the different examples: removing users, disabling services, or disabling or removing services. So the other thing that we can do to hardening our system is enabling a firewall also. And there's different examples too, but this is hardening basically. So if you want to harden a system, we can achieve this by two ways. One is the executing system commands to harden that system, and the other one is mostly about standards, hardening standards, and it includes some tools for automating the hardening process. So these are the common techniques.
And what are some of the typical types of threats in terms of the attack vectors and some of the general categories of security issues that operators should be considering?
So I face elevation of privilege attacks or attack vectors most of the time, but there is also some network issues that like some vulnerabilities that will let users to spoof network packages or send malicious requests. So these are the two common things that I face, and considering those type of threats, hardening should be an important term to developers and the operators as well.
So, can you describe a bit about what the GrapheneX project is and some of your motivation for creating it?
So, GrapheneX is an automated system hardening framework. So, before I give an explanation about the project, I want to give a quick shout out to my friends that helped me to build the GrapheneX, because we are a team actually. Actually, we're friends, but we created a team called GrapheneX team, and I lead the project. So their names are Ömer Faruk Oruç, Enes Okutan, Efe Aydın, Furkan Yüksel, Tayfun Kalaycı, and Taylan Doğan. They helped me to build the GrapheneX project. So I like to mention about the name of the project too. So graphene is a is it's a atom thick layer of carbon atoms arranged in a hexagonal lattice. So it's about 100 times stronger than the strongest steel. We chose GrapheneX name because graphene is something stronger than the strongest steel, and we try to harden systems. So we think it's a good relation between these two names. And X is just a suffix that we like to use while we creating projects. So GrapheneX project is automated framework. We call the project a framework because there's different features and different commands that you can run, or different type of things that you can do, and it's automated because there's a thing called presets in GrapheneX that will automate the process of hardening. So we try to provide a framework for securing the system with hardening commands automatically. So we have some. We actually I like to mention about the motivation behind it before I go into the technical details. So we have a group at Telegram with my friends. We always like to do things together, like projects. So one day tried to we decided to make a project together, and we were thinking. One of my teammates, if I didn't just send a repository to our group, which was hardening checklist, Linux hardening checklist. It contains different hardening commands for hardening your Linux system. So I was like, can we just automate this and put these commands in a framework that will run depending on the user designment? So we just they were okay. We decided to create a project for this purpose. and we just try to design the project for end user as well as the Linux and Windows developers. And the basically it executes hardening commands on the backend side, and there's a web side of it too. And that's basically it about GrapheneX.
And you mentioned that it helps to automate executing this list of commands for being able to improve the overall security of a system. I'm wondering if you can talk through an example workflow of somebody using GrapheneX to harden their system and some of the options that are exposed and just some of the overall decisions that they need to make as they're interacting with the software.
Okay, so first of all, you have to install GrapheneX. Obviously, you can achieve that by building from the source or using the pip package. We have a pip package called GrapheneX, and after that, you have two options for hardening your system with GrapheneX, which are using the interactive shell or the web interface. Interactive shell, we developed this side of the project for the people that are used to the Linux operating system, and there's commands for hardening. And when you go to your terminal and type the name of the project GrapheneX, it will give you interactive shell. You can list commands with help command, and it's very easy actually. You can switch to namespaces or modules. We call the hardening commands modules, and the part of the let me think here. And every individual module affects a part of the system, so we call that part a namespace. There's different namespaces there. You can switch to them with the switch command or use command for selecting a module. Then hardening command will execute the hardening command of that module automatically. The other option for using GrapheneX is the web interface. You can start the web interface with the -w command parameter from from your terminal, or just typing web into your interactive shell. It will open up a it will start a web server to access the GrapheneX web website of the GrapheneX. And there's an extra precaution there, which is the access tokens, because you can access the web interface from different machines if you start with the localhost parameter. But we try to prevent this with the access tokens, so it will request an access token for redirecting to you the actual GrapheneX interface. So when you start the web interface from terminal, it will give you an access token, and you can access your web interface with that access token. So these are the two ways of using GrapheneX. The web interface is quite simple to use because there's a list of modules that you can see the uh, hardening commands or execute the hardening command. There's a drop down menu for seeing the namespaces, and that's pretty much it.
And for performing this hardening on a single server, it's obviously easy to choose between either doing a web interface or a command line for somebody who's comfortable in either environment. But for using this across a fleet of servers, when you're trying to automate deployment, I'm assuming that you would just use the command line, or is it possible to generate a configuration file that GrapheneX can consume and then run the automated set of routines that you want given the profile of the instance?
Actually, there's not a feature for this type of operation, but you can use the web interface for these type of servers, or there's a Docker file that you can use to automate these this process. But actually, no, that we don't support this type of thing. But we can, improve the framework for this purpose.
And as far as the security controls that you're enabling, sometimes it can end up interfering with the operation of software that you're actually trying to run on the system, such as maybe you accidentally close down firewall ports that are necessary for a network interface for the networked application that you're trying to build, or sometimes some of the, for instance, AppArmor profiles and Debian-based systems can interfere with proper operation of a piece of software. So I'm curious if you have any safety mechanisms or warnings built into GrapheneX to let people know that this might end up interfering with their software, or maybe some way of detecting what software is running and then letting people know that if you enable a particular profile or a particular command within a namespace, that it's going to prevent a piece of software from working?
Oh, this is a good question, because when we try to find eligible modules for the framework, it's something that we always considered. So we have modules, then modules have the description of the OS command for the hardening process. Actually, we try to give every detail about that command to user with the information section of the module, but we don't have a control mechanism like that for preventing running the commands that you said. But we always try to uh, inform user about that command, and most of the commands require the root access, so we warn users about them, but we don't warn about the contents of that module. Instead, we try to inform about the contents of the module, and user should be careful about what he or she is doing about that module. So we don't have any warning mechanism or checking. We do not check the service or the file content before executing the hardening command or the module. But we try to inform the user basically.
Can you talk through a bit about how graphene is implemented at the sort of technical level and some of the ways that the overall system design and capabilities have evolved since you first began working on it?
Of course. So we have a team. So we try to keep things simple, and we try to choose a program language that everybody knows and capable of doing some things with it. And we choose Python to move on. We started with writing the interactive shell. We used the Python's CMD module for it. It was pretty much it has the features that we wanted. We create the interactive shell with it. Then we moved on to the web interface, which is currently Flask and Socket IO based, but we will probably change it later to something else. Actually, we have a pull request that will change the entire backend side of the web interface, but we use the Flask for now. And the hardening process was handled with the standard built-in libraries, and we used them for executing a system command. That was We didn't use anything external for this purpose. And other things like the logs and the colored logs, we used the colorama and colored logs module. And printing is handled with the terminal tables library, and some commands request user input, and we used py-inquirer library for the prompt. And this is pretty much it about the technical side of the project. We try to keep it simple. And the on the website, I have to mention about the JavaScript and HTML and CSS, the classic way of creating simple websites. Actually, I'm not a web guy, so Faruk handled all the web side of the project, and this is pretty much it about the technical side of the project.
And if you were to start the whole project over now that you have gotten further into it and have a better understanding of the overall problem space and some of the design constraints and possibilities, are there any aspects of it that you would change or anything that you would do differently?
Probably I will start with the finding modules, because it's the hard side of doing a project like this. you have to find eligible modules for the framework, and we did it at the end of the project. We created our modules.xml file, which contains all of the modules. At the end of the project, we basically finished all the features. Then we tried to find modules or create our own modules. So I will probably start with that step because you can't find or create your Linux or Windows commands easily and quickly. So I will start with that, and probably I will use a different technology on the website of the project because we're just changing it right now to React. I don't know why actually. It's probably more optimized than the Socket IO and the Flask. I will probably think more about the web interface, and I will just lead the project according to that changes.
And as far as the module interface, what is involved in actually creating a new module? And are there any gaps in terms of the current implementation that you are looking for help as far as adding new capabilities to the framework?
Okay, so if you want to add a module to the framework, there are three ways of doing this. The first one is using the manage command from interactive shell. It will ask you inputs about that module. Actually, there's three things that you can do with manage command. First one is adding a module, the editing a module and removing a module. So if you choose the add option, it will ask you about ask you the module description, name, and the OS command that will run for the hardening process. You can use manage command for the adding a module, or you can add modules from the web interface. It's pretty simple. There's a button for the adding a module, and you'll see a page that will ask for the module details. And the third way is editing the modules.xml file directly. We use that file for parsing the module details and listing them, or any other operations. So if you modify the modules.xml file, it will change the module details on the framework. Since we try to design the GrapheneX very abstract from the modules.xml, you can just change that file for changing the purpose of the project, because it basically takes the hardening commands from that file and executes it depending on the user input. So there are three ways of adding a new module. So we we have an open issue for the GrapheneX contributions. It's about adding modules to the framework, obviously, because we can improve the framework technically, but backend on the front end side. But we need modules for framework to run or operate as expected, and it's important to add more modules to the framework. So we accept contributions to the framework in terms of modules.
And for the different modules, do you have any built-in testing for verifying when they run effectively, or to prevent a duplicate run if a particular setting has already been configured?
Actually, we do not test them with any type of tool, but we test them on our systems or the virtual machines. It's like a process of approving a pull request. All of the team members have to approve the module before we add into the framework. And we use our own systems, but we use virtual machines to test those commands too. So it's the technique that we use for testing modules before adding to the framework.
And as far as your experience of building GrapheneX and working with your friends on improving it, what have you found to be some of the most interesting or unexpected or challenging aspects of the project, and any particularly useful lessons that you've learned as a result?
The interesting part of the project was learning frameworks, especially Flask, and the website is something that I'm not used to do. I'm not used to. So it was interesting to learn different technologies while working on this project. And the challenging aspects of GrapheneX was the obviously the finding modules and creating modules. And since I lead the project, it was even harder to split the team for finding eligible modules for the framework. And it was not my first experience, Python experience, but some technical stuff was challenging too. Like you can write the same program with different approaches. So we have a team, so we have different opinions. We were always thinking about which is the optimized way of doing something. It was challenging, but it was fun. So that's it, I think.
And then, as far as your understanding and experience of server and system security, how has that grown as a result of working on GrapheneX? And are there any areas of system security that you have consciously avoided implementing in GrapheneX just because they would either be too difficult or too bespoke?
So when I was working on GrapheneX, I had a chance to know my GNU Linux setup better because we were just experiencing different things with the modules and the Python. So it was a good experience for me to learn my learn the internals of a Linux system. And the thing that we tried to avoid was the firewall exploits or firewall threats, because it's something hard to configure in my opinion. It's not for every user to configure a firewall or the network, because there are tools for it, but mostly they use IP tables on Linux. And we try to avoid different threats by adding different modules about network configuration IP tables. And it I hope it will help users to understand the internals of a system. But these are the things that we try to avoid, mostly the firewall and the network things. And I hope it will help users to understand the operating system internals.
And what are your overall goals for the GrapheneX project? And what do you have on the roadmap for the near to medium term as far as new features or overall system improvements?
And probably we will add more modules and we will improve the web interface. The other than those goals, we do not have anything like anything big or anything that will change the whole purpose of the project. But we will try to improve according to the user feedback. And I think it's a project that we should keep alive, because there are some open source projects that is in dust, but they are working so well that people are still using it. So we try to keep project updated, so that people can still use it on different machines and different systems. We basically, this is our goal, to keep the project updated and keep the modules updated for the individual services or configurations. So that's it about the goal.
And as far as the system support, it seems that the majority of the focus is on Linux, but I'm wondering if you have experimented at all with running it on any BSD based systems or any other operating systems that you're planning to target.
But actually, I'm talking like the GrapheneX is just for the Linux, but it's not. It support Windows too. But since I'm using Linux, I just think it's just for Linux. But we plan to test the GrapheneX on different systems, because we think that we can automate the hardening process on the systems to like BSD or other things. We plan to do that, but right now it supports Linux and Windows. The Windows part is a little bit wider than the Linux because Windows has Windows modules are uh, target more parts of the system than Linux. It depends on us actually. It was not about the Linux or Windows, but we try to find or create modules for different operating systems.
Are there any other aspects of the work that you've done on GrapheneX or your experiences with managing system security and hardening processes that we didn't discuss yet that you'd like to cover before we close out the show?
So I can talk about the ways of the way that we choose for hardening, the technique that we choose. There are different techniques for hardening a system. First one is using a checklist or list of commands, and the other one is tools, which is a GrapheneX is a tool, and third one is standards. There are some standards actually for hardening, so they call CIS, I suppose, and or different standards like PCI DSS. They have different approaches for hardening a system. They target most of the time Windows, but we did not choose this approach while implementing GrapheneX because the standards are maybe sometimes too strict that they won't let you to do things that you want. So we try to use checklists for GrapheneX to automate the hardening process. So it's you can use those checklists for manually hardening your system too, but the GrapheneX is automated. It will do things automated for you, and actually it's a framework, so it will help you to harden your system. And I like to talk about the automated part of the GrapheneX, which has the preset command for running different modules at one with one. Okay, let me explain this again. There's a preset command that will run set of hardening commands from different namespaces or a namespace or a single namespace. You can adjust or change the modules.xml file for changing the presets. Mostly we target a part of the system. So there is a preset called kernel access restriction that will run two modules for restricting the kernel access without permission. So it will run two modules in order to hardening a specific part of that system. So we try to give GrapheneX an automated design for with the preset command.
All right. Well, for anybody who wants to follow along with you and get in touch, I'll have you add your preferred contact information to the show notes. And so with that, I'll move us into the picks. And this week, I'm going to choose chess because I've been able to spend a bit more time recently playing with my kids and my dad. So it's good to revisit it every now and then. So if you haven't found the time to play chess or you haven't learned it yet, it's definitely worth a shot. It's a fun game with a lot of different strategies involved. So definitely recommend that for anybody who's looking for something to pass the time. And so with that, I'll pass it to you, Orhun. Do you have any picks this week?
Yes, I have a band called Cryoshell. It's originally makes there's a Lego set called Bionicle, and they make the advertisement or short film songs for the Lego set Bionicle, and I think they are very good at this job, and their songs are amazing. I will pick two songs of them. One of them is Creeping in My Soul and Gravity Hurts. They are very amazing songs. I suggest everyone to listen them. So that's it.
Well, thank you for taking the time today to join me and discuss your work on GrapheneX. It's definitely an interesting project, and it's targeting a very necessary space for people to understand, and it's great to make that a bit easier for them. So thank you for all of your efforts on that front, and I hope you enjoy the rest of your day.
Thank you. Have a good day.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.